Problem solving in 2 dimensions isn't that much more difficult than problem solving in 1 dimension, but you always have to do both the x and the y motion. And so let's just do an example, and I'll walk through what that actually means. So here we have a ball launched off of a 20-meter tall cliff. So this cliff is 20 meters high. And here's the ball, and it's going to be launched. If it doesn't say if it's launched at an angle, it's always going to be launched horizontally. So this ball is launched horizontally, and so you and I both know that it will follow a path that looks something like this. And the question is, how far from the edge of the cliff does it land? What's this x position? Now, that how far does it land, that's also called the range. So if somebody might ask that, like, what's the range of this? So nothing has changed in how we do this. We read the problem. You can highlight the important stuff, 20 meters, 14 meters per second. Then we need to draw the diagram, which we've already drawn, and label the things that we know. The one difference is that we're going to split our variables into x and y. And so y is going to be our vertical, up and down, and x is going to be our horizontal motion. So we know x initial, x final, acceleration in the x direction, initial velocity in the x direction, vix, initial velocity in the x direction, vfx, and t. These are all of the variables that you're going to need. And you'll have those same variables over here. Now, our initial x position, if this is our origin, our initial x position is 0. This is 0 meters. And our final, well, that's what we're looking for. Now, the acceleration in the x direction, remember, things don't accelerate horizontally, especially, we never have air resistance, so there's nothing slowing it down. So that acceleration in the x direction is going to be 0 meters per second squared. Our initial velocity in the x direction, that's just this, vix, 14 meters per second. And that's going to be equal to the final velocity. So you can put this if you want to, but these two things are equal because it's not accelerating. The last thing is the time. I'm actually going to write the time here because the time is what links the x and the y. So the time that the ball is in the air that's the same time that the ball is traveling horizontally as the ball is traveling vertically. So the time is the link. So what's our y initial position and our y final position? Well, our initial position in the y, it starts at 20 meters and it ends at 0 meters. And then the acceleration in the y direction, this is just gravity, right? Negative g, negative gravitational field strength because it's accelerating downwards due to gravity. Our initial velocity in the y direction, VIY, is going to be 0 meters per second because it's not being shot up and it's not being shot down, it's being shot horizontally. And we don't know our final velocity in the y direction. We could calculate it if we wanted to. So that's something that we don't know. And we don't know the time. Okay, so how do we get the information that we want from here? Well, we need to maybe choose an equation. So we'll choose an equation. The whole goal in this is to find how far. We don't have enough information in the x direction to do that yet, so we need to use the y information to solve for time first. This will always be the step. We want to solve for time first and then take that time and plug it into our x equation because we know that the velocity final, is this what we know? Yep. The change in position over the, nope. Yeah. Change in position over the change in time is the velocity. This is for when the acceleration equals 0. And so we can find our x position by our change in position if we take our velocity times the time. So we need the time first. All right, so how do we find the time? We come over here and we think about our equations. So I'm going to write those down. VF equals VI plus acceleration times time. Change in position is V naught time plus 1/2 AT squared. And then there's one that doesn't have time in it, and that's VF squared equals VI squared. But if it doesn't have time, why are we going to use it to find the time? I look at this equation and remember I don't know the final velocity, so that equation doesn't make sense to use. So I'm going to use this equation, and I'm just going to rewrite it without the x's, and I'm going to rewrite it with y's. So I'm going to scroll down a little bit. Okay, so I'm going to rewrite this as the change in y is the initial velocity in the y direction times the time plus 1/2 acceleration time squared. The initial velocity in the y direction is 0, so this whole term goes away. Now delta y, that's our change in y, our final position minus our initial position, or the displacement. The ball travels 20 meters downward, so this is actually going to be negative 20 meters. That equals 1/2 acceleration, which is negative 10 meters per second squared, times time squared. And so negative 20 equals 5 negative meters per second squared. We'll put meters here, second squared, time squared. Divide both sides by negative 5. Divide by negative 5. We get t squared equals 20 divided by 5 is 4. Take the square root. Take the square root. So we get our time of 2 seconds. This is going to work out swimmingly. Okay, so we get a time of 2 seconds. So now our change in position, now that we have the time of 2 seconds, we can put that into this equation with our initial velocity here. So our change in position is 14 meters per second multiplied by our time that it's in the air of 2 seconds. So this is going to give us a change in position, or a range of 28 meters. That's basically all it is. Write down the information for both the x and the y, solve one of them for time, and plug it into the side that you need to know. That's it.